The Monty Hall problem was conceived from a game show called Let's Make a Deal, where the host, Monty Hall, would present the contestants with 3 doors. Behind one door would be a car, and behind the other 2 would be zonks, or unwanted items. He would have a contestant choose one door, and then would proceed to open one of the other 2 doors. The door he opened always contained a zonk. After the door was opened, he would ask the contestant if they'd rather stay with their door or switch to the unopened one. Contestants who switched had a 2/3 chance of choosing the car, whereas the contestants who stayed only had a 1/3 chance. This is because the 2/3 probability that the car is behind one of the other doors doesn't change regardless of which door he opens. Given the fact that he does open a door with a zonk, it concentrates the 2/3 probability on the final door. Therefore, when given the option, you should always switch because the odds are greater. When looking at the graph, it is assumed that you always choose door number 1 for this experiment. For example 1, the car is behind door number 1. Then, Monty reveals door number 2 and asks if you'd like to switch or stay with your door you've chosen. In this case, if you stay, you win the car, and if you switch, you get the zonk. For example 2, the car is behind door number 2, and Monty shows you door number 3 with one of the zonks behind it. He again gives you the option to switch or stay. In this case, if you switch, you win the car, and if you stay, you get a zonk. For the final example, the car is behind door number 3, and Monty shows you door number 2 with the zonk. Again, if you switch, you win the car, but if you stay, you get the zonk. This table proves that it's always better to switch because in this scenario, you would have won the car 2 out of the 3 times. However, keep in mind that this is a probability, and that means there's no guarantee that you'll win, it just means you're more likely to. It may be difficult to see when there's only 3 doors, so let's look at a bigger scale. In this case, Monty presents you with 100 doors and tells you to choose one. That one door has a 1 in 100 chance of the car being behind it. That means the other doors have a 99 in 100 chance of the car being behind them. Monty then reveals 98 of those 99 doors with zonks, and then proceeds to ask you whether you'd like to switch or stay. Now, you can practically see the concentration of the probability that the car is behind the one door Monty didn't reveal, and you're almost inclined to switch. On a larger scale, it's easier to see the logic behind switching over staying.